Okay, this is a podcast on what are limiting reactants and excess reactants, what they are, and how to calculate them. First off, a limiting reactant is the reactant that limits the amount of the other reactant and also limits the amount of product that can be formed. You also know the limiting reactant because it is used up in the reaction. So it is completely used up and consumed in the reaction. The excess reactant is the substance that is not used up completely, so there is leftover in an excess reactant. Here's a chemical reaction in which you've got carbon and oxygen. Clearly you can see that carbon is the limiting reactant and the excess reactant is the oxygen. Here you have an example of another type of problem where you would have to figure out the limiting reactant. Here you have 3 hydrogen plus nitrogen making 2 ammonias. When we look at this reaction as far as what is in the beaker here for you, you'll notice that you have, you've got 6 N2 molecules and you have 1, 2, 3, 4, 5, 6, 7, 8, 9 H2 molecules. But the limiting reactant is actually the H2 because the H2 is going to combine with the N2 to make NH3 and you will have 2 N2 molecules left over. How to calculate limiting reactants? There is a mathematical idea of how to calculate these. Here in this reaction, silicon dioxide quartz is usually quite unreactive but does react with hydrofluoric acid according to the following equation. If you have 6 moles of HF and they're added to 4 moles of silicon dioxide, which would be the limiting reagent? To solve this, the first thing you have to know is that you need to have both of your components in moles. So if I give you an amount in grams, you need to convert it to moles. Secondly, you then pick one reactant, you're going to compare to the other reactant, and then you're going to use logic to solve this problem. So I'm picking HF and I'm comparing with a mole ratio the silicon dioxide, and notice that I have 4 moles of HF. That 4 moles of HF is comparing the mole ratio that I have right here. 4 moles of HF to 1 mole of silicon dioxide produces 1.5 moles of SiO2. So in order to use the full 6 moles of HF, in order for that all to react, I need 1.5 moles of SiO2. Do I have that much? You look back and you say, yes, I have 4.5 moles of silicon dioxide because that is what was given in the problem. So I have enough. That means all of the HF can be used. Therefore, the limiting reagent is HF. You may also see, like in your homework problems, this could potentially be in a book problem, a problem like this where tin 2-fluoride is used in some toothpaste. It's made by the reaction with tin and hydrogen fluoride according to the following equations. Here it says how many grams of SnF2 are produced from the reaction of 30 grams of HF with excess tin. Well, since you know that the tin is in excess, that means the HF is the limiting reagent, and that is what you're going to start your calculations with. So you take your 30 grams of HF and you convert to moles of HF. You use the mole ratio to convert to moles of tin 2-fluoride, and then you would use the molar mass to solve. And whatever number you end up here with, you would report 3 sig figs because you started with 3 sig figs. So that's just like the typical stoichiometry problems we have done all last week. And you know that HF is the limiting reactant because it said tin, which was the other reactant, was the excess reactant. All right, we also went over how to do some calculating of limiting reactant problems how to calculate how much product is formed, and how to calculate excess product formed. This is like the worksheet that was handed out in class. This is the first problem in the worksheet, and I want you to follow through with that. If you have 75 moles of magnesium and it reacts with 12.4 moles of HCl until the following reaction is complete, there should be an arrow here. What is the limiting reactant? Well, to do that, the first thing you would have to do is to figure out, pick one, and I picked magnesium. I had 75 moles of magnesium. I did a mole ratio to figure out how much HCl would be produced, and then I used that logic. In order to use the 75 moles of Mg, I need 150 moles of HCl. Do I have it? Well, you have 12.4 moles of HCl, so yes, you have enough HCl. That means the limiting reagent, I'm sorry, you don't have enough HCl. You have 12.4 moles of HCl, you need 150 moles of HCl. Therefore, the limiting reagent is HCl. Part B of that worksheet says, calculate the number of moles of product formed. Well, to calculate the number of moles of product formed, you're going to want to start with the limiting reagent, which you've calculated in part A. You know HCl is the limiting reagent. So you're going to start with HCl, and you are going to calculate how many moles of HCl, how many moles of magnesium chloride then would be formed. You do that work and it becomes 6.20 moles of magnesium chloride are formed. There's two products, as you look at, there's an arrow here. There's two products. Not only is there magnesium chloride, there's also H2. And if you notice, the ratio here for both of those are 1 to 1. Therefore, you can say that 6.2 moles of H2 are also formed, since it is a 1 to 1 ratio. Part C of this equation here says how many grams of the other reactant, known as the excess reactant, remains. Well, to do this work, you're going to want to start with the limiting reagent as well. I start with the 12.4 moles of HCl because that was my limiting reagent, and I compare back to the other reactant. The other reactant in this equation is magnesium, so I'm comparing, and I am calculating that 6.2 moles of magnesium are used when all of that 12.4 moles of HCl is used up. I then subtract that 6.2 moles that were used from the amount of moles that were available in the problem, which there was 75 moles of magnesium, as you can see right here. There's 75 moles of magnesium that are available. So that means after the reaction, 68.8 moles of magnesium remain. I then take that 68.8 moles of magnesium and I convert to grams by the molar mass, and I get 16.70 grams of magnesium. The other reactant, the excess reactant, remains. That is how you do that worksheet that we handed out in class today. I hope this helps. Good luck. Make sure you stop in if you have questions.